Okay, we start. Components. Okay, today we want to talk about the component of u along v, namely the component of u in the direction of v. If you see something that looks like this is vector v, this is vector u. The red refers to component of u along v. Whoop. Call that theta. Well, you tell me, you super smart trig people. If you wanted to find that component, what would you use? Okay, we got a nice little 90-degree triangle, like that. Cosine of theta. Oh, very good. My good friend Nathan sees that if you would that the cosine of theta in this situation is equal to the component of u along v. We'll call that a divided by the length of u, which is the magnitude of u. And if you simply multiply both sides by magnitude of u, you get the magnitude of u times the cosine of theta, which happens to also be, we don't have time to do this, but in your book they do show that that ends up being u times v divided by the magnitude of v. So we have two ways to calculate that. Now you guys use trig and use cosine to be able to find that, but we can also just simply use u times v divided by the absolute value of v, or the magnitude of v. Any questions? Let's apply it and make it work. Flip your notes over. It says find the component of u along v. Well, again, we know that the component of u along v is u times v divided by the magnitude of v. So that's what I'm going to do. And when you first look at that, don't you just kind of want to cross out the v's? You do, but you understand that that's not how vectors work. That's not how vector addition, subtraction, multiplication, division, anything like that works. So we take u times v. Do you remember how to take this vector u times this vector v? What do? 1 times negative 1 plus 2 times 4. Very good. Divided by, how do we find the magnitude of v? Square root of a squared plus b squared, or negative 1 squared plus 2 squared. Yeah. What would you like to do instead? Oh, no, it doesn't matter. Sorry. Sorry I did that. No, 4 times 2, 2 times 4 is both 8. Multiplication is commutative, so we're okay. So we're going to figure this out. We have 1 times negative 1 is negative 1. 2 times 4 is 8. Add them together, we get 7. Divided by, on the bottom, we have the square root of 5. This is our final answer. That is the component of u along v. However, the fact of the matter is that we do not want to leave it in that form because we need to rationalize the denominator, so we multiply the top and bottom by the square root of 5 to get 7 square roots of 5 over 5. Taylor did not like that. What do you think, TD? All right. So, you want to try next one on your own, or you want me to do it with you? How do I rewrite 3I minus j? 3 negative 1. There you go. So we do u times v on top, which is 3 times 1 plus negative 1 times 1 divided by the magnitude of v, or the square root of 1 squared plus 1 squared. And on top we get 3 plus negative 1, which is 2, divided by the bottom is the square root of 2. Multiply top and bottom by square root of 2. You get 2 square roots of 2 over 2. 2's cancel. Square root of 2 is your answer. Any questions about that? Devin, you did not like that. You made a small mistake. Very good. Any questions on that? So my good friend Ryan McLaughlin, I don't know if you know him, but he was complaining about the length of the assignment today. So if you have some problems like that, do you think you can do those? Ryan says no. It's too long. Everybody else, second hour, said, can we just stop with that? Can we just leave it like that? Stop making fun of my speech impediment, or I'll start making fun of the way that you look. All right, yes, I did. I already did. Naomi, is that uncalled for a teacher to make fun of students? Or do you think that's more appropriate? Do you think that makes class more fun, actually? You know, well, I'm doing my master's right now on the impact of graphic organizers in the mathematics classroom. I would like to redo it. I want to do the impact of making fun of students in the mathematics classroom. See if that actually increases learning, if that keeps your focus. What do you think, Robin? What would we find out? It probably does. So let's just make fun of everybody every day. All right. So, okay, now we want to apply it to a word problem. Let's apply it to a word problem. It says a truck weighing 4,000 pounds is parked, it says parked on a driveway that's inclined 30 degrees to the horizontal. Yep, sorry. So I've got this truck. And as you guys know, my drawing is far superior to Nathan's. That is a truck. I think everybody recognizes that. Yeah, take that. You look like a kazoo. There's an antenna. Okay. Leave me alone. All right. So it's on an incline at 30 degrees. 30 degrees. And 4,000 pounds. Now, weight is, as we calculate weight is really, kind of how our body responds to gravity. What direction is that force? Straight down. So if you notice here, and second hour kind of got hung up on this vector, this force straight down is 4,000. Is that agreed? I also have two vectors that I want to think of in this situation. One would be the magnitude of the force required to prevent the car from falling down the driveway. So that would be this vector right here. And then we also have another vector. It is the magnitude of the force experienced by the driveway. Well, by definition, an object experiences a force perpendicular to it. So that represents what the driveway is experiencing. So let's just ask the question. You got a 4,000-pound truck on a 30-degree incline. Do you think you could keep it from rolling backwards? Okay, we'll see exactly how much force you need to exert in order to make that happen. You'll soon find out that you'll be flat as a pancake. So it says find the magnitude of the force required to prevent the car from falling down the driveway. I want to find this red one right here. I need to find that. And so as you look at this, I need some angles. What is this angle right there? That angle right there between the red and the blue. 60 degrees. Because you know that this blue vector, which represents the weight of the object, is going to be perpendicular to the ground. That's what gravity does, moves perpendicular to the ground. So we have that 60-degree angle. So let's focus on the red. How are you going to find this piece right here? We will call it A. How are you going to find A? Somebody tell me. Cosine of 60 degrees is equal to A divided by the hypotenuse. And the hypotenuse would be the magnitude of the vector, which is 4,000. Would you agree? Solve for that. A is equal to 4,000 times the cosine of 60 degrees. Anybody know what the cosine of 60 degrees is? 0.5, 1/2. 4,000 times 1/2 is 2,000 pounds. Do you think that you could honestly exert 2,000 pounds of force? No. I don't think that you could. I don't think you could keep that truck from rolling down that driveway. That'll be pretty tough. What's that? Oh, wow. That sounds like animal cruelty. You wait till PETA watches a video like this, they'll come find you. You want to stick elephants in front of that. I don't know. I suppose. Does it now? How do you kill a pink elephant? Very nice. I like that. How do you kill a pink elephant? Shoot it with a pink elephant gun. How do you kill a blue elephant? No, hold its nose till it turns blue or pink. No, it's the other way around. how do you shoot a blue elephant? Shoot it with a blue elephant gun. Then how do you kill a pink elephant? Hold its nose till it turns blue, then shoot it with a blue elephant gun. That's the way the joke goes. You can tell it later on, huh? You're terrible looking. I have terrible jokes. I would rather have the latter. Yeah. Yes. Yep. So how about this angle right there? Now we need to work with the green. The green is the force experienced by the driveway. That is 30 degrees. Very good. And so now we need to calculate the magnitude of the force experienced by the driveway due to the weight of the car. So as you can see, I have 4,000 gives my hypotenuse, and I'm looking for this adjacent side. So again, which trig function will I use? Cosine. The cosine of 30 degrees is equal to, we will call this length B divided by 4,000. Multiply both sides by 4,000. Samantha, you have a question? Well, you can see that by definition, the green vector here is perpendicular to the surface. It's perpendicular to this. So therefore, it must add up to 90. So we have 60 and we have 30 makes 90. Is that okay? Devin, then Jalen. No, again, you have a 90-degree angle formed right here. So 4,000 is the hypotenuse. B is my adjacent side. Okay, so you're looking a little bit different. That's okay. And Jalen. Well, the red line and the green line are horizontal and vertical components. And so therefore, if you were to do this squared plus this squared, you would get the blue squared. So I'm just trying to reference that and trying to be smart with it. But the fact is if we took the red and added it to the watch, to the green, we should get the blue. If we do vector addition, we should get the blue. If we take the two forces and add them together, we should get the other one. Does that make sense? You'll be very smart. You really just need to kind of tie up your loose ends in your homework tonight, you guys, and then really be ready to ask questions tomorrow and get ready for your study guide. I think once you see the study guide, you'll feel much more comfortable with what you're going to be asked to do on this test. I don't think that the test is going to be nearly as bad as what you would think. However, I didn't think that about 7.1 through 7.5 either. So once again, I could be entirely wrong. So let's do this. So we have 4,000 times the cosine of 30. 4,000 times the cosine of 30. And we get 3,600 or 3,464. So that's the force experienced by the driveway. Okay, that's the force experienced by the driveway. Are there any questions on that? You guys asked some very good ones right away. I guess at the end of the day, Jalen, I would just encourage you to try to make a right triangles. And in the end, that should work out. Okay, we are skipping projections because we simply are running out of time. So we will move to the backside and we will do work. You can cross out projections. I will cover them next year. I will find time. This year I have no time. So we define work. Work is equal to force times distance. Or work is equal to F times D. So if I, push a 1,000-pound car 10 feet, my work would be 10 times 1,000, which is 10,000. But it really depends on the angle which I'm applying the force. It depends on, is the object simply moving horizontally? Is it moving vertically? One thing we are not calculating in here also is friction, which happens. So it says find the work done by force, F, in moving an object from P to Q. Well, I want you guys to think about this first. I'm moving from P to Q. I'm moving from 0, 0 to 3, 4, okay? So I'm moving from here to 1, 2, 3, and 1, 2, 3, 4. So am I moving it in a positive direction or a negative direction? A positive direction. And what I need to do first is I need to find that that displacement. And you might first want to find it in terms of, a squared plus b squared is c squared. But we're going to leave it in vector form. So namely, in order to find this distance, the distance is going to be equal to the point where I end up minus the point where I began from. And so if you do q minus p, we have 3, 4 minus 0, 0. If I subtract those, what do you get? 3, 4. So that is the vector that represents my total displacement of the object. Yes, you can see you're over 3 units, you're up 4 units. That would make the hypotenuse 5, but we're not going to think about in terms of that because we want to multiply it by a vector. So work, again, is equal to force times distance. Or W is equal to, the force is I plus J. In vector form, that is 1, 1. So we would have 1, 1 times 3, 4. Okay. So what's 1, 1 times 3, 4? 1 times 3, 3. 1 times 4 is 4. We add them together, you get 7. Because we learned yesterday that in order to multiply vectors, you multiply the x values added to multiplying the y values. I'm sorry, multiply the a's added to multiply by the b's. So that's the dot product that we learned yesterday. Dot product property. Let's do the second one. Force is equal to 3i minus 2j, point P 0, 3 to Q negative 1, 2. Let's look at this. You start at 0, 3, 1, 2, 3, and you're moving it to negative 1, 2. Did I move that in a positive direction or negative direction? Pretty much negative. So you can expect that we will have negative work done as it represents that type of direction. So force in this situation, as you can see, is going to be written as the component vector 3, negative 2. And in order to figure out the distance, I have to take distance is equal to Q minus P. So my end point minus my beginning point. Or negative 1, 2 minus 0, 3. And when we do that, we get negative 1, negative 1. In order to calculate work, I take my distance and I multiply it by my force, which is 3, negative 2. When I multiply those together, I get 3 times negative 1, which is negative 3, plus negative 2 times negative 1, which is positive 2. I get negative 1. Any questions? So could you do problems like that on your own? What do you say, Mr. McLaughlin? You can do it. I'm very proud of you, Ryan. Okay, we'll end with this last problem. We are going to talk about, again, a lawnmower. Now we had Devin be an impartial judge the other day, but she was hardly impartial. What's that? Are you okay with it now? I think. All right, I like my lawnmower. All right, the handle's at 35-degree angle to the ground. 35-degree angle to the ground. The lawnmower is being pushed a distance of 80 feet at a constant force of 60 pounds. So we are going to say that this red vector right here represents the force being applied by the individual pushing the lawnmower, 60 pounds of force. And I'm going to choose this point at which he's pushing the lawnmower, he or she, to represent our beginning point P, which will be 0, 0. If he or she pushes the lawnmower 80 feet horizontally, where is going to be my ending point? 80, 0, because it's a horizontal push, so our x value will change, our y value will not. In order to calculate the work, the question is find the work being done. Well, work is equal to force times distance. So in order to figure out my distance, I will take Q minus P, or 80, 0 minus 0, 0. And I come up with 80, 0. Is that any surprise? No. So 80, 0 will be my distance multiplied by my force. Now I have to figure out my force. Well, my force, just like my distance has a horizontal component and a vertical component, my force has a horizontal component and a vertical component. Namely, if we look at this, you have a vertical component of your force, we'll call that B, and you have a horizontal component of your force, we will call that A. How do we calculate A? A is equal to, very good, 60 times the cosine of 35. How do you calculate B? 60 times the sine of 35. So let's figure out what those are. $60 cosine of 35, and I get 49.15. And then, if I do 60 sine of 35, I get 34.41. Now, I want you guys to just think about this for a second, okay? Let's just forget about the stuff we've been talking about and just think about the actual problem. If work is defined as force, amount of force you applied times the distance that the object is moved, how much work have I currently done to this door right now? How much distance has it moved? None. So how much work have I done? None. I haven't done anything. So this lawnmower, as I'm pushing it horizontally, okay, what has been the change of the lawnmower vertically? 0. So what kind of work have I done vertically? 0. And as you notice, when we multiply this out, you'll see that the vertical component of the work will be 0, that we only have horizontal work being done. So as you can see here, as you multiply these two vectors, we have 49.15 times 80. So I take 49.15 times 80, and I get 3,932. Plus, I have to take 34.41 times 0, which is 0. So you can see that this represents, again, the horizontal portion of the work and then the vertical portion of the work. We have no vertical component to our work at all because it hasn't moved at all vertically. Have we, true or false, we've applied some vertical force? True. We've applied 34.41 pounds of force down and 49.15 pounds of force horizontally. And that's made up 60 pounds of force. Okay? But this is how it works out. We because there's been no change up or down in terms of the position of the lawnmower, our end result is 3,932. And here's how we write it. We moved it a certain number of feet, and we applied pounds. So it's foot dash pound. That's the label for work. Foot pounds. For those of you who are mechanics similar to torque. Okay, so that would be an example that I would ask you to do. We're not going to do example 7. We've already done an example like it. I'll give you your assignment, page 609, numbers 19 through 21. You're going to have some time to work on your stuff, I think, right? Well, that's it. You guys get out early? There's your assignment. It seemed like we had more time second hour. Maybe that's because we didn't make fun of anybody. We always seem to have more time this hour. I don't know what's going on. Well, 30 minutes. Wow, I guess. Gosh, 30 minutes. That means we should have 15 minutes. But you guys get out, don't you? This class is shorter. That's too bad. All right, there you go. There's your stuff.